So thank you. My name is Elena, and I'm a PhD student in Universitat de Catalunya, in UPC here in Barcelona. Actually, I'm working in laboratory calcul numerics, so what we do is try to understand some kind of problems by means of numerical simulations. And in particular, we are interested in lots of problems which are interesting from an engineering point of view. Today I'm going to present a little bit some kind of models that we use to simulate, to understand how materials behave when they are subjected to load or to displacement. So let's start first with these two pictures here. Here it's an experimental three-point bending test. So imagine that you have here this beam, which is clamped here, and what I do is I apply some kind of force here on the top side. So what do we observe experimentally is that a zone starts to be cracked, but first that we see this macroscopic crack, what we see is that there is a zone which starts to be less stiff as it used to be. If we see here this house, we see more or less the same. We have some kind of macro cracks, but is it working? No. But if we see this detail, we see not only this crack, but also all these diffusive micro cracks. So the idea, obviously, we do not want to break a house every time that we want to understand some kind of properties about the material, but the idea is to have a numerical tool which allows us to have a complete simulation. So we can, from numerical point of view, we can use different kind of models, continuous models, discontinuous ones, and the combined strategies, so that they combine continuous and discontinuous approaches. And the idea of continuous, it's like the word says, the idea is that all the displacements, stresses, strains are continuous profiles, so are continuous quantities. And from a numerical point of view, what we use is the finite element method. On the contrary, if you use discontinuous models, we cannot use finite element method. Why? Because now that our quantities are not continuous anymore, so we need to extend a little bit our approximation basis. So that's the reason why we use this extended finite element method. So now the functions that we use to approximate quantities, the functions that we use to approximate displacements, stresses, strains, now can be discontinuous. Here I have written just some reference for those who are interested in, but if we look at the years, we see that some strategies are becoming trendy, this combined strategy, and the idea is that they start with displacement which are continuous, but somehow in the middle of the computation they switch the model and they start to use discontinuities. And by means of this combined strategy, we are able to simulate all the process from the very beginning when the structure is not damaged anymore at all, but also to the final step. So more or less it's what we can see here. So by means of continuous strategies, we can model the first stages of the process, but on the contrary, since remember that we are using continuous functions to approximate the quantities, we are not able to deal with parts of the simulation, parts which are really physically are separated. On the contrary, if you use discontinuous, we are able to model the last steps of the process, but not the first ones. And combined strategy allows us to simulate all the process, the complete description. But since we are switching from one model to the other, obviously we need to take special care doing this kind of switching. So I don't know if I'm good at. Well, I would like to show you a simulation. Just yes. Bueno, I'll play. Yes. So here, just to see more or less what we do, here we have in the structure, the three-point bending test that we have seen in the first slide. So what we see is that we start with a continuous strategy, so the structure is continuous, the damage evolves, and when the damage is so high, we introduce some kind of discontinuity. Here we have the force displacement curve, and well, by means of this combined strategy, we're able to reproduce all the process. So that's all. If you are interested, we can discuss in the coffee break. Thank you.